All right, this is part two of chapter one of the Rathus textbook. The last video, we sort of looked at what psychology is, where it's come from, how it's advanced sort of from philosophy now to a full-on science. We looked at some of the different perspectives in psychology, kind of the ones that sort of define psychology early on and have helped sort of shape it into the science it is now. We're going to start back up and kind of continue on discussing the scientific method. And if you look at the picture on the screen now, which is figure 1.5 from the textbook, this sort of diagrams the scientific method in a nutshell. You've probably seen charts like this similarly in other courses, or maybe even as far back as like elementary school when you first heard about the scientific method. It typically begins with observations followed by research questions that are oftentimes influenced by prior research. And those research questions serve the basis of forming hypothesis, which you then go into testing the hypothesis by gathering evidence. Based on the evidence, you're going to draw conclusions. Was the hypothesis correct or was it not? If it was correct, we might then begin into developing theory, more research leading to a theory construction. If the hypothesis was incorrect, then maybe we need to modify it, for example, and develop new research questions. And kind of start back over. So it's a very iterative process, a cyclical process. Typically, most scientific endeavors you should come away with more questions than answers. So some of these are the steps I kind of already talked about now, but typically, you begin with a research question, state the hypothesis, which is an educated guess, and it's not just a guess; it is typically educated by previous research. You're going to test the hypothesis, draw the conclusions. We'll talk more about correlation as well in a few slides, but just know, depending on the type of research you have, you don't want to confuse your results of correlation, meaning confusing correlation results with cause and effect. We'll talk more about that in a couple slides. So when psychologists are conducting research of any kind, they are typically drawing from samples, and these are just portions of a population. It wouldn't make a whole lot of sense financially or logistically for a psychologist to, for example, survey or measure, attitudes about a particular topic. Let's just say like a political topic or something. It would make a lot of sense to survey every single person in a population, like every single person in the United States. That would take too much time, too much money, and by the time you got all the results, people's attitudes may have already changed. So typically what researchers do, psychology and otherwise, they use samples, they use smaller segments of a population to draw from. Oftentimes, you'll see, a national poll on from a political newspaper or website or TV show that'll say, survey shows 53% of Americans support, legalization of marijuana. I'm just making something up. And they'll say something, a sample of 1,000 people, plus or minus. That means that they're taking their quote unquote national sample is coming from, or the population is being drawn from a sample of only 1,000 people. And we could be we should be somewhat dubious, or I guess skeptic of results like that, because sometimes we have to wonder, where did that 1,000 people, that sample, come from? If you sample 1,000 people from one particular city, that's not representative of the United States as a whole, then you have a biased sample. But if your sample comes from equally from all parts of the United States, for example, maybe it's a little less biased. Okay, so here let's kind of put this into work. So truth or fiction, you could survey millions of voters and still not accurately predict the outcome of a presidential election. True or false? The answer is true. In fact, this happens a lot of times. In fact, it happened with the last presidential election. There were so many polls and exit polls and things like that that thought they were going to accurately predict the outcome of the presidential election, and most of those prognostications and predictive models were wrong because other factors are at play. Sometimes people change their minds. Sometimes people lie about their intentions to vote. Sometimes we just don't sample the right people. So there's just a lot of things at play. So my recommendation is just to sort of be careful when consuming data. Be very skeptical. Always ask, where does it come from? Some more on samples. Oftentimes, the best samples are ones that are generated randomly, meaning everybody has an equal chance of being a part of the sample. It means you're not just only drawing, only female participants from the sample or only males. Everybody has an equal chance, regardless of their gender or regardless of the race, ethnicity, whatever. Samples are typically better when they are also stratified, meaning they're represented proportionally to the population. So if the population at large has a dynamic of gender breakdown of 55% females and 45% males, you would ideally want your sample to look that way as well. You wouldn't want a sample of 75% males and 25% females, because that's not exactly how the population looks. Again, I'm just making these numbers up, but I'm just to illustrate the point. And the point is because you want to be able to generalize. You want to be able to apply what you find in your research from the sample to the larger population. So if our samples aren't random and they're not stratified, it makes that generalization much more difficult. And researchers also have to be aware that there might be a bias in the very people who sign up to be a part of research studies. It's called volunteer bias, and a certain type of person may be more likely to sign up and participate in a study than other types of people. And that doesn't mean like race or ethnicity or anything like that, but there just might be a mental mindset of differently for people who sign up for research studies and those who don't. So here's an application of some of this stuff that we've just talked about. Here's a scenario for you. Emily, a committed environmentalist, reads a report that among a nationally representative sample, 60% of people polled support offshore drilling in California. The poll includes 1,000 people. Emily scoffs at the results, noting that all of the people she knows do not support offshore drilling. The poll must be flawed. How do you evaluate Emily's statement? So my recommendation is to go ahead and pause the video and maybe jot some ideas down and think about this question, maybe why you think, what do you think about Emily's evaluation of the statement, or how do you evaluate Emily's statement, excuse me. So go ahead and pause the video and come back and tell me, and let's see if we're on the same page. Okay, yeah, so you paused, you're back. I think, Emily is right to kind of scoff at these results. 20,000 people, if we're talking about, it says a nationally representative sample of people. I mean, the United States has over 300 million people, so it might be kind of difficult to draw big conclusions from only 1,000 people. And again, I mean, think about if it's coming from California. I mean, that could have a certain bias. I mean, maybe people think differently on the East Coast versus the West Coast, or the Midwest versus the West Coast. I mean, so there's a lot of things going on here, a lot of reasons to sort of be skeptical about these results. So if you came up with some other reasons, that's fine too, but those are a couple of things that I kind of picked out just glancing at the scenario. So let's move forward. Psychologists gather data in a number of ways, one of which is called a case study. It's where you study a very small group of individuals or people. Typically, these occur in clinical settings. Typically, it's investigating something rare, something that doesn't occur often. In fact, Sigmund Freud's entire theory of psychoanalysis is built upon the use of case studies. He studied 8 lonely, wealthy Austrian housewives in the Victorian period. Very specific, very hard to generalize to everyone as a whole, but it's a very interesting idea. Case studies typically aren't used to sort of generalize findings. They're usually used to illustrate some sort of rare occurrence or phenomena that's happening. They're really interesting, but again, just kind of hard to apply at large. Surveys are pretty straightforward. You've probably taken a dozen surveys by now in your life, maybe hundreds or thousands of surveys if you've ever completed like a customer satisfaction survey after going to a restaurant or a store. The idea is to be able to gather a lot of information really quickly and sometimes cost effectively. Send out a survey to 1 million people and maybe you get 100,000 back. It's a quick way to gather information. It's a quick way to collect information about people you can't necessarily observe directly or manipulate experimentally. Another method of observation is called naturalistic observation. If you've ever gone to the mall and people watched, then you've done this yourself. This just means observing subjects, human or non-human, in their environment, in their natural environment. So if you have pets and you've ever just kind of watched your dog play in the backyard, or you've gone people watching at the mall, that's naturalistic observation. And a good example of this is the picture in the right, Jane Goodall. She is famous for studying chimps in the wild. She learned things about chimpanzees that we had no idea. behaviors that we had no idea about because we just didn't see them perform these behaviors directly. For example, she found out that chimpanzees engage in behaviors that are very similar to warfare, that they will, one tribe of, or one group or pack of chimps will wage war against another for resources. Something we just didn't know about until she went into that environment and studied them directly, and I'm pretty sure she still does to this day. Correlation I mentioned earlier, this is a form of research where you are identifying relationships between two or more variables, just to see if they're related. You can't really say that A causes B, but you can say that A is related to B. The reason why we can't say that A causes B is because, well, what if it's the other way around? What if B causes A? Or what if there's something else at work? What if there's a third variable, C, that's actually causing A or B or vice versa? Or D even, there's all kinds of things that are at play. So usually correlation research is just used to show that, hey, these two things are related to each other. It's measured on a scale of +1 to -1. And 0 meaning there's no correlation. The closer we get to +1, we would say it's a positive relationship. The closer we are to -1, we would say it's a negative relationship. And I'll show you what that means graphically in a moment. So we have a graph on the left, which is intelligence test scores and grade point averages. We would say there is a positive correlation between these two, meaning that as intelligence scores go up, we would also expect GPA scores to go up. And we can kind of see this in the graph. If you look at the graph, the points are kind of going in a linear direction from the bottom left-hand corner up to the top right-hand corner. And the opposite is happening on the graph on the right, where we have levels of stress compared to immune system functioning. And here we see a negative correlation, meaning as our levels of stress go up, our immune system functioning goes down. And you can kind of see a line. If you were to draw a line right down the middle of this graph, it would show the opposite, a negative correlation. As one variable goes up, the other goes down. But again, we can't say that intelligence tests cause higher grade point average because, again, maybe it's GPA that causes higher test scores, or maybe there's some other factor at play like diet or environment or something else. The gold standard of all research in psychology is the experimental method, and this is where researchers can actually manipulate variables and measure and manipulate variables. You have the independent variable, which is what is manipulated. So, for example, in a drug therapy, it could be, getting a drug versus getting a placebo, a sugar pill, or something that's meant to kind of trick you into thinking it's a real pill. Dependent variable is the outcome, what you are measuring. So maybe it's if we're testing a new antidepressant drug, maybe the dependent variable is scores on a depression scale. Maybe we want to see those scores go down as participants take medication. Typically, experimental research uses at least two groups: an experimental group, the one who receives the treatment, and a control group who does not. Typically, they're controlled to serve as like a baseline for comparison. Sometimes it's important to use single-blind and double-blind elements to your study. In a single-blind study, your participant doesn't know whether they're part of the treatment or the control condition. So in the case of like an experimental drug therapy, the treatment or the participant wouldn't know if they're receiving the drug or not. In a double-blind study, both the participant and the observer are not aware of which group they belong to. So in this case, the researcher, maybe the therapist, for example, doesn't know if the participant is taking the drug or taking the placebo. The point of this is for the researcher not to treat all participants equally, to treat them the same, and not be biased towards one group or the other. Okay, so truth or fiction. Let's check our comprehension real quick. In many experiments, neither the participants nor the researchers know who is receiving the real treatment and who is not. The answer is true. Double-blind experiments are very common, especially amongst, when you're testing out new experimental therapy methods or drug treatment for treating like depression and anxiety. Very, very common. And here's what this might look like, if we were here's an example you can read about in your textbook, Figure 1.7, using, drinking vodka versus drinking water, and reading about their beliefs and whether they're drunk or not. And it's a pretty interesting study, but I won't spend too much time on that. Let's go ahead and check our comprehension real quick. Let's go back and talk about correlation. You can pause the video and check your own comprehension, but a correlation of negative 0.67 indicates what? A, a strong positive relationship, B, a strong negative relationship, C, a weak positive relationship, or D, a weak negative relationship. Go ahead and pause the video and check your comprehension. All right, welcome back. The correct answer is B as in boy, a strong negative relationship. Again, this number 0.67, negative 0.67 is getting pretty close to -1. So the closer we are to -1 or +1, we would say it's a strong relationship. And obviously the negative sign indicates, hey, it's got to be a negative relationship. It's important to, one of the last things we'll talk about, is ethics in research. It's important to understand that there are ethical considerations to take into consideration when dealing with humans and non-humans. In fact, most universities, most research institutions have an ethical review board that you have to go before and basically justify your research. I work at the University of Oklahoma, and any research that I do at that university, I have to go before what we call the IRB, the Institutional Review Board, and basically tell them why I think my research would be beneficial and also how I'm going to conduct this research ethically in a way that doesn't lead to harm. Because that's the number one goal of any kind of ethical consideration in research and psychology is do no harm. So some of the ways that this is prevented, preventing researchers from doing harm knowingly or unknowingly is, for one, is to have the individuals who participate to give informed consent. You have to get participants' consent in order for them to participate in your research. If they can't consent or won't consent to be in your research, they can't be a part of it. And you also can't coerce them to consent either. That would be highly unethical. The APA, it's, some of the research we're going to talk about in this course and some of the research you've probably heard about, maybe in pop culture or otherwise, sometimes use deception. Sometimes you have to lie to participants. But there are ethical considerations, ethical standards when it comes to lying or deceiving participants. And for one, the benefit has to outweigh the harm. Deceiving a participant, if it is harmful, you have to have some really good benefits from it in order to get that approved. They also have to believe that individuals might have been willing to participate if they understood the benefits of the research. So if it's one of those things, if it's kind of on the fence, hey, if it's for the greater good, if we can, another thing to consider is participants have to be debriefed afterwards. You have to inform participants, hey, we lied about this, but here's why. It's to achieve these purposes. Typically, most people are going to be cool with that. Hey, you deceived me, but hey, you let me know afterwards. Some people might still be bothered with it, but that's, that's something that really has to be considered up front before you go to the IRB and then when the IRB is reviewing your research. Same thing with animals. Again, do no harm. Really, you only want to use animals in research if there's no other alternative and if there is clear benefit for why you're using animals and potentially justifying harm. And again, there's really strict standards. You can't just come up with a research project where you get to shock rabbits or something like that, or deprive rats of food or anything like that. You have to be able to justify. It has to be really no other alternative. It's a pretty strict standard. So, like all sciences, psychology is you can apply the principles of critical thinking to psychology. Any of the research that we look at in this class, any research that you see in your everyday experience, whether it's reading online or whether it is, reading a newspaper or an article or whatever, I highly recommend that you apply principles of critical thinking and how you consume knowledge. First of all, be skeptical. And that involves insisting on seeing the evidence. Don't just accept claims as they are, face value. Look, where does the claim comes from? What's the bias? What is the sample size? All kinds of things that you really need to take into consideration. Don't take words for face value. Actually think about where the definition comes from. Think about your own biases, assumptions. All of these things that might be influencing the way you think and the way you see the world. And also just be really cautious about drawing big picture conclusions from the evidence you are presented with. Don't just read one research article and draw the big conclusions. Look up another one, that of similar. Find an article that disagrees with the article you just read. Find ways to see both sides. again, allow room for alternative interpretations. Try to avoid oversimplification in your thinking, and again, try not to overgeneralize things. And this, I think, is applicable not just to this class, not just when you read articles on Facebook or whatever, but really just be kind of apply critical thinking to all areas of your life, your relationships, your aspirations, your goals, all, everything in your life, is worth critically examining. We only get one life, so it's important to live it and enjoy it and maximize it. And I think being critical thinkers is one of the ways that we can maximize our experience. So, anyways, that is it for chapter 1. I'm going to wrap it up here. I don't have a comprehension question for you to wrap up. We will jump back into chapter 2 shortly when we get into the subject of the brain and biology and psychology. So thanks for tuning in, and see you in chapter 2.